You're listening to ChainLeak, the crypto news podcast with your host, Joshua Roomsberg. Follow and subscribe today.
Welcome to the ChainLeak podcast. I'm your host, Joshua Roomsberg. Today's episode is about Taraxa Network, a BlockDAG Layer-1. Today's guest, the DeFi developer lead, Ellard Varga. Welcome to the show, brother.
Thanks, Josh. Thanks for hosting me. It's an absolute pleasure to be here.
All right, great. So for the listeners who may not be aware of the term BlockDAG, could you give us a quick breakdown of what that means and how it differs from other blockchain networks?
Oh, yes, of course. I was waiting this to be the first question because it's a groundbreaking change. It's actually the natural way of how decentralized networks innovate. That's like a normal step from 1 to 2, basically.
Yeah.
And I'm going to summarize it in a very, very short and elegant way.
Okay.
Current chains that are out there, like Ethereum, Solana, Bitcoin, and all these, let's call them current chains.
Yep.
They all have one big problem, which is they can introduce one block at a time.
Okay.
So this kind of like creates a data structure that is linear, right? So there's one block after the other block after the other block. It creates a chain, right? But decentralized networks are not chains per se. They are more like trees. And BlockDAG actually builds on top of this, and it enables decentralized networks to include more blocks into the same chain at the same time. So that's why I'm saying that it's a natural evolution, because think about all the like electricity and all the computational power that's getting lost in between Ethereum and Bitcoin validators when they are creating these blocks. Like only one.
Some blockchains even have I don't know a term for it, but I consider them dead blocks that have nothing intrinsic inside each of these blocks, but it's still producing blocks every minute, every 10 minutes. And them are just empty blocks going to the blockchain. So I get what you mean there with wasted energy and wasted resources. So BlockDAG has the ability to push through more blocks, is what you're saying?
Yes, exactly. And the term that you were referring to when you said dead blocks, those are basically filler blocks, if you want to consider them like that.
Yeah. And
they are created to keep up like a quality of speed for these block creations, so that the network doesn't like run a wall saying that, oh, something bad is happening.
Nothing happened on the network, right?
Yeah, nothing happened on the network, but I still need to produce something because I'm configured to produce something, and then I just use my computational power to deliver nothing, basically.
Yeah. Okay.
And
so
that this is.
Yep. Go ahead.
And that this is not even the biggest problem. The problem is that when it comes to redundancy, all the different nodes on a decentralized network, they kind of calculate the block on their own, right? And those blocks are just getting lost. Only one of them gets elected to be part of the blockchain. So yeah, that's the biggest problem when it comes to energy efficiency. And that's one of the main problems that BlockDAG can solve, besides scalability itself.
So now, BlockDAG, do you guys have wasted blocks using this type of network?
We don't have wasted blocks per se. However, obviously we cannot just like right all the wrongs of usual blockchain technological like draw-ups architecture. What we can do and what we have in BlockDAG is duplicate transactions. We do have duplicate transactions. Unfortunately, there's no way of getting around that. But all the blocks created on a BlockDAG are introduced into the chain.
Okay, so every single block gets included onto the chain instead of like with Bitcoin, you may produce 100, 200 different transactions, but all of them blocks are going to get wiped off and only one's going to get accepted into the blockchain?
Yes, that's true. That's true, because when you think about transaction inclusion, only the one block that is getting voted by the majority of the network is going to get inserted on Bitcoin. Now, on BlockDAG-based networks and on Taraxa, all the blocks that have at least one transaction inside are getting included into the DAG layer of the network. We call those blocks DAG blocks just because of this, because it's easy to understand. So
Okay.
it might happen that two transactions are included in two different block DAGs, or three transactions have different like have different slots in these block DAGs, but all of them are getting included, and that's a major thing.
Now, what is the outcome of having a block get included twice? Are there
So
any
when
vulnerabilities or shortcomings by having that?
Yeah, so there is a research paper that we based our technology on by three Israeli researchers, and what they said is that it's not that important to reduce duplication per se. What's important is that you need to have a clear, defined enter path in between these blocks, so that there is always a clear definition of transactions that you can trace back. So this is the way of how you validate BlockDAG based networks, and how you actually like defend against Sybil attacks, defend against wrong or malicious transactions being included, and just false transactions in general. In
Okay.
Taraxa, yeah, do it.
Yeah, no. So, me personally, I'm trying to visualize what you're talking about. And what I picture is, say I send a transaction for $100, it gets to the receiving address, but it doesn't necessarily mean that there could be anything bad by that block getting included in the block DAG multiple times, because it's still my wallet sending it. It's still that wallet receiving it. It's the same amount. Now, does the time that the transaction starts, is that the only thing that would be different in the blocks? Is there anything different between the two blocks, or are they exactly the same?
So we are not including duplicate DAG blocks on that manner. So for example, like, do you know how transaction hashes are generated based
Yep.
on the metadata that's included inside the transaction itself? That transaction hash is a unique identifier of the transaction. Now, if there's a block that includes nothing else but that same transaction, and it comes from two different nodes, their block hash is going to be exactly the same. Therefore, the network Taraxa itself is going to recognize that, hey, like, this is the exactly the same block. So I'm not going to take it twice, right? Because it doesn't make sense.
So it's not going to be, the blocks are not going to be identical. It would just be the transaction itself that could go in multiple blocks.
Yes, exactly.
Okay.
And also blocks can differ on amount and length of transactions too, because think about a way that, like, you are running, let's say, a Taraxa node, and some people are connected to you, some people are connected to other nodes,
Someone
right?
else all
You
over in
might
the world. Yep.
Exactly. You might get 5 transactions coming into your end, and then the other node can also get one of your transactions, but can have 5 different other transactions coming in. So at the end, they are going to have 6 transactions, or going to have 5 transactions. Those two DAG blocks, even with having one duplicate transaction, are going to be 2 different DAG blocks.
The blocks are not duplicate blocks. You're not producing the same block twice on multiple machines. It's that transaction could come to me first, and then it could come to you, and it's the same transaction. It's just whether or not my block comes first or your block comes first.
Yes,
And it's
exactly.
the same information. It shows the receiver, sender's wallet, the amount, all of that information is the same. It's just the time that the block gets there.
Yes, exactly. So ideally, one transaction should go through all the network, right? So
Yep.
thinking about a node that is right at the end of the network physically, and is the farthest from actually connecting to the network itself. It should get basically all the transactions from all the different nodes.
People
So
before it.
if
Yep.
yeah, exactly. So if you think about a hypothetical scenario in which it doesn't create the DAG block before, but it waits all the transactions from all the other nodes and then creates a big DAG block, it should have that initial first transaction
Transactions
from
in
the
it
first
anyway.
node, right?
Yep.
Exactly.
Okay, so that's really unique when you think about that versus, say, Ethereum. when you run an Ethereum transaction, it gets included into one block and one block only, and you have to wait until one miner is going to accept your fee that you're willing to pay for that transaction. So it could take 2 minutes, it could take 30 minutes for that Ethereum transaction to go through. Now, when you compare that to Taraxa Network, how fast do your transactions go through on general?
I think our finality is one of the quickest. Now there are some newer chains like Solana and Sui that are like almost up to date, like they don't have any finality. Our delay is, I think, at around 3 seconds,
Okay.
or even less depending on network circumstances. But all our benchmarks and all our tests that we did were on like Raspberry Pis and very cheap, very minimalistic hardware. So I think if we are actually getting all the Taraxa nodes inside one server room like Solana does, we can achieve almost instant finality too.
Okay.
So the main rule here really when it comes to the networking effect and to finality of a transaction is that once your transaction is included inside the DAG block, it's final. It's going to be on the chain.
Yep. Okay. So now when you compare the two networks again and you think about the cost per transaction, when using Taraxa Network, what is the cost per transaction in general? And will that cost per transaction exceed $1, $5, $10 in the future?
It's impossible.
Okay.
Currently, we are running our mainnet since like late March of last year. I just did a benchmark because I was helping a community-led DEX called TerraSwap to launch, and they did their like first test transactions and test batches on our mainnet. They were able to do more than 2,000 swaps with 1 Terra token.
Okay.
So to make a simple transaction on the Taraxa network right now is like point God knows how many 0.2 cents.
Okay.
So it's almost negligible.
That's great. That's great to hear. Now, when you think about future applications and businesses and retail users using the network, could you see the potential for each of these wallets to hold one Taraxa token for transactions, say over a year, 2 years, 5 years, just based off that one token?
It depends on the frequency of their transactions, right? So if they are sending multiple transactions in the time frame of 1 second, they might run out, but for a general purpose use of simple on-chain transactions, one token could really be enough for a year.
Okay. Because
which is absurd to think of.
Yeah, no, that's wild. That's what I like to think about, because I was just telling somebody this morning, they were talking about a meme coin on Tron. And I said, I cannot use Tron, me personally being in the business, knowing that the transactions on Tron right now are like $1.50 per transaction. And when you think of the overall retail user, they're going to think about the same way they use a Visa or a MasterCard. They want the transactions as low as possible to where they don't recognize that when they're moving their funds around. So when I look at the meme market on top of Tron Network right now, that's suffering because the cost per transaction is so high. To whereas you compare it to Solana transactions are so cheap that you can move around and not have to worry about the transaction fee moving your funds. So when you look at Taraxa Network, what are the limitations as far as the cost per transaction in the future?
Yeah, so I think that I think you nailed really the pathway there. I think like meme coin trading on Ethereum, that's never going to be a thing, right? High frequency trading on Ethereum is never going to be a thing. Then Tron was the next step, right? Tron is kind of like the middle ground in between Solana and Ethereum,
Yep.
but it's still unfeasible to do small amounts in a single transaction because it's just not worth it, right? Now Solana came at a really good time when these other chains, BlockDAG based chains, Taraxa, weren't really like recognized from and weren't really tested out. And I think Taraxa itself is going to get, it is going to be like the natural next step after Solana. Like, you realistically cannot battle with a MasterCard, you cannot battle with Visa if you're even charging like $1 per transaction.
Yep.
It's
Right.
really an interesting thing, because we just had a debate on Twitter, because one of our OG community members pointed out that you can do a single transaction out of like a small amount of a small amount of a small amount of a cent on Taraxa. And then there was another like outlier community member, I don't want to name the community, that just came in and said that that's exactly why the token doesn't have a value, because it isn't actually like paying itself for
Being
gas
used for the
fees.
transactions, right?
Exactly. And then I came in and actually my question put a point to the end of the debate, unfortunately, because I just asked them that, do you not really think that like having a layer 1 native token uh, paying for itself on the form of a gas fees is more in the form of gas fees is more of like a built, not a built-in natural utility, but like a made one. Like,
Yep.
these networks are not like, Taraxa was built to actually handle informal data and IoT transactions in between automated entities. That was our thing in mind. Like,
Okay.
we want the chain to be as scalable and as quick and as cheap, so that you are going to put all your data and all the things that you cannot build and you cannot put on top of Ethereum right now, or you cannot even put on top of Tron right now, because it's just like too expensive. You keep all the other things in your database, you just put
Yep.
like the transactional data inside, right? Now Taraxa is built to actually solve that without the necessity of having layer twos.
Okay.
So yeah, I think that having the argument of like your token being used in multitudes of like dollars for gas fees is not the way to go, and the current blockchain scene is really not ready for global adoption just because of that. You just cannot expect people to pay multiple dollars for a simple transaction. It's
Right.
just not realistic.
It don't make sense at all. Could we talk a little bit about the low cost hardware required to run on the Taraxa network?
Yes, of course. I think that right now in the blockchain space, this is a very overlooked aspect of inclusivity. And we are talking about decentralization here. Like, everybody is trying to just do like the decentralized ethos and live around it. And in the meantime, we are building networks that require like not even server grade, but enterprise server grade hardware to run like a simple node.
Yeah.
Take a look at ICP. I was just lately at one of their hacker houses, and when I asked them that what's the requirement to run an ICP node, they said that like, you as a normal human being, you cannot do that. Like, you need dedicated hardware to do that. You cannot even do it from like a cloud. It's just too much.
Yeah,
Like,
that's wild to me. And I hear people talk about ICP a lot. I've personally never even ventured over there because I didn't understand the concept of the requirements to even get involved on that level. Um, what types of requirements were they mentioning when you were at the hacker house?
they were mentioning like Microsoft level server requirements,
Okay.
like it's insane, like multiple hundreds of gigabytes of RAM
Yeah.
and stuff like that. It's it's definitely not done for with inclusivity in mind, and that's sad, because it just like cracks the ethos of decentralization. Now with Taraxa, we built our core business logic in the layer 1 with decentralization and inclusivity in mind, and that I think concludes really well in the fact that one of our core ledger developers was running his own like test Taraxa node on a Raspberry Pi that was just like, yeah, connected to his Wi-Fi, with a couple like 100 or 150 gigabytes of memory and like 1 to 4 cores. I can't exactly name it, but like very, very low
Small,
requirements and
right?
like 4 gigabytes of RAM. Yeah. So basically you get like a 150 bucks of Raspberry Pi, and you can run a Taraxa node, especially a light node. And it doesn't actually impact your staking revenue.
Okay.
So yeah,
Now,
you cannot get cheaper than that.
another thing is you mentioned the cloud. Do you have the ability to run a cloud node for Taraxa?
Yes, of course you can. Actually, we have detailed information and like detailed explanation on how to do that on our documentation site. Take a look at it at docs.taraxa.io. We outlined like probably most of the like most widely used cloud providers there and how you can set up a Taraxa node there. The top requirement is really right now with the current state of the mainnet, if you want to run a full node at around like 300 to 400 gigabytes of storage and then some minimalistic amount of RAM. But realistically, it's not even using that. And for to run a light node, it's at around like 100 gigabytes or something. It's for
Okay.
running a blockchain node. It's these are like stupidly small
Right.
benchmarks to hit.
Now, do you guys have any on-chain requirements for running a node?
Yes, we have only one requirement. So, in order for your node to actually get included into the consensus, you need 500,000 Terra tokens to be staked. This is like ensuring fairness and ensuring that like the network is not bombarded by, let's say, shadow validators or shadow nodes.
Yeah. Okay, so that makes sense. So, for any of the listeners who would potentially want to run a Taraxa node, 500,000 tokens is what would be required on top of the hardware requirements for running a node for the network.
Yeah, and that's very important to mention there that if you're actually an A gamer in marketing and an A gamer in community, or just you just like to hang out with the OGs at on Telegram or Discord or whatever, you can actually solicit this delegation from other community members. So if you're there to actually showcase that your node is going to perform well and you have top notch like tech to actually run it on, then most of our community members will anyways help.
Another product that is being built on the network is Lara. Now, does Lara have any implications on the amount of nodes being run on the network?
No, it doesn't really have, just because we are actually like running it with a very different mindset.
Okay.
Again, focusing on decentralization, meaning that Lara protocol, as it is a liquid staking solution, is not run by affiliation of nodes. We are actively scanning the totality of the node pool on the Taraxa network, and we are just simply going for the best ones.
For the best
There is
validators on the network. Okay.
Yes, for the
I
best
gotcha.
validators on the network. And it also has almost like instant redelegation times, meaning that in a very short time frame, it calculates and reframes it again.
That
And then if one of the nodes that is being chosen for delegation is actually not producing the best results, it just takes the delegation away and then moves it into a better one, right?
that was the next question I was going to ask is when it comes to the validators, when you're using Lara, are they repositioning automatically? Or do you have to go in and redelegate every time a provider is not meeting the minimum requirements?
No, you definitely don't need to do that.
Okay.
We created a protocol with ease of utility in mind. Most of the community members are anyways not that tech savvy when it comes to staking. And I
Yeah.
think that like the barrier of entry to staking shouldn't be that high, so that like you need to look at like, oh, is this validator better than the other one? Should I stick with this for like a longer periods of time? No. I mean, that's a very easily automatable process.
Do you guys
Um,
have any cooldown periods whether on the network directly or when you use Lara?
Cooldown periods in you mean like on staking?
Redeeming your assets. Yep.
Ah, yes, redeeming your assets. Yes, so there is an improvement proposal right now that is being voted on the Taraxa network and the Taraxa governance platforms. It's called TIP 4, Taraxa Improvement Proposal 4, that shortens the undelegation period and the cooldown period from 32 days, which was until now, and is still effectively active right now, to 7 days, on the majority of the
Yep.
EVM
Like
chains.
I have some TRX I staked, and right now it's locked in for 14 days. So I can't do nothing with them funds until that 14-day period passes. There's another network, Atom. I think their cooldown period is 30 days or 31 days or something. So them funds are locked in and you can't move them. A 7-day cooldown period, I think, is really needed for these networks. Like, it's cool to be able to get in, but you got to be able to move your funds if you need them. And a 30-day wait period, I think that is just terrible. So if you guys can get it down to that seven day, I think that would really help with the growth of the network as well.
Yes, I totally agree with you. Hence why I actually started the improvement proposal.
Okay.
So that I was the one that drafted it. I was the one that actually started the discussions, and I'm 110% certain that it's going to pass. So yeah, I think we can even talk about welcoming the 7-day on delegation period on Taraxa now. So yeah, I'm that confident.
Another thing I'd like to touch on is the evolution of Taraxa's T-graph consensus. Can we talk about how that has evolved over time of the network?
Yeah, so I think that was the main reason why we were testing the network for so long. I mean, if you check up Taraxa, it has been a venture. It has been a thing since 2019, and getting EVM on a BlockDAG is actually not that easy as any other person would think, because we just took out the consensus layer from the Ethereum virtual machine and then added BlockDAG in there, and then the execution layer is still Ethereum virtual machine, which is really good because you can just take your Ethereum application and put it on Taraxa. That's how easy it is.
Oh, that's sick.
Now the T-graph consensus is actually what makes all of it to have a common sense, a common purpose. It's the way of how we are entering the common path or the longest path inside this directed acyclic graph, hence where the DAG abbreviation is coming from. So think about it as a longest path of consecutive nodes back to the Genesis block that were still elected as part of the main chain of these different nodes inside the DAG network. Those are the ones that are having the biggest weights inside the network, and those are the ones that are actually elected to then have their information become a PBFT block. That's the main block, and that's kind of like what resonates one-to-one to an Ethereum level block on Taraxa. So if you're going to go to our Explorer, you will see that on the left-hand side, you will have a bunch of DAG blocks that are getting included a lot quicker into the network. And then on the right side, you're going to have a bunch of PBFT nodes that are coming every 3.7 seconds.
Right.
Hence, our finality is at around 3 seconds, because your transaction is included if it's getting into a DAG block, but in order for it to be 100% sure that it's not going to be reorganized inside the network, it also needs to be included into the first PBFT block.
Okay. Now, when you look at the overall landscape of the Taraxa network, what types of products are people bringing from other EVM compatible chains onto the network? Are there any specifics that you've seen that really stand out?
Yeah, so I think that right now, since we are at the genesis of the ecosystem, most of the things that we see are the base building blocks of DeFi, the base building blocks of DePIN, and the base building blocks of meme coin and meme ecosystems coming into the chain, like multiple sorts of flavors of dexes, let it be Uniswap forks or PancakeSwap forks or Balancer forks are coming in. We are getting quite a lot of really cool inquiries from the DePIN world.
You talked about the different use cases when it comes to, say, DeFi and DePIN. What types of DePIN products have you seen inquiry about the network?
So one of the biggest use cases, I think, and it's very natural that that's going to be the biggest use case, is high frequency trading. It just makes sense, right?
Okay.
You have multiple millions of transactions. We had multiple inquiries to be built on top of Taraxa. Quite a lot of like high frequency traders from Web2 are actually like really leaning towards moving on cheap chains. And we also need to consider that there are quite a lot of people that are running centralized and closed chains for them to actually have their tech stack up and running. So that's also another like opportunity for Taraxa to have all those solutions in a public ledger.
Now, you talked about DeFi on the network and DePIN projects. I'm thinking more about the storage aspect in AI. What types of infrastructure could be built on the Taraxa network when it comes to data storage and artificial intelligence?
Yeah, so as I already said, Taraxa was created with the focus on informal transactions, having in mind,
Yep.
meaning that the chain should be able to handle all the different sorts of information that people just store in their centralized databases, and then have the essence of their information on blockchain, and then just interact with it. Let it be like metadata, transactional data, user data, etc., etc. The name of your cat. You can just put it on chain with Taraxa, because the nodes are built in a way to actually sustain that information. And we were always like, I mean, we are conducting experience, we are developers, it's a developer first layer one, and we have Echo protocol that is being built for like almost 1.5 years now, that's ingesting, we just surpassed yesterday more than 15,000, oh no, 15 17,000 public Telegram groups.
Okay.
We are ingesting all those messages from there, and we are building sophisticated LLM models and AI models to actually use that data. And yeah, most of it is on chain.
Wow.
Have you ever guessed for that something like that would be available? And it's not ICP.
Right. No, so that's another thing I think about is like the data sets. I'm real big in AI. I use AI in everything I do every single day. So for blockchain and AI, the intersection of the two industries, I always think about the possibilities and what types of networks are available, products are available, and what can really be built when you think about the next 5 to 10 years. So that's a perfect transition into the next 5 to 10 years for Taraxa Network. What do you guys see for the future of the network when you're building this out? You mentioned DeFi, DePIN, artificial intelligence, data, whether big or small. What other improvements or types of products can you see coming to the network over the next 5 to 10 years?
Yeah, so I think I would like to highlight one use case that nobody really talks about besides me, which is, so first and foremost, I think that blockchain is a match made in heaven for AI agents. It's like an entirely like consensus algorithms per se are going to be big, and I think consensus algorithms are actually the biggest like treasure that we got with all this boom and all this research in the blockchain ecosystem.
Yep.
And in the long run, we will see AI agents having consensus algorithms in between each other, and we're just going to be cut off as humans because we enjoy having sunbathing in the beach and enjoying life more than actually chunking data and doing data battles. Uh, and then if you think about a platform that is able to ingest social data, so basically it knows what are people talking about and what are people thinking, and then also sees what is happening on a blockchain. Now that's really interesting because it provides you like a holistic view of the world, and it's not cut off at the point where like what could happen versus what is happening. It has it everything in one place. And I think that with Echo Protocol, we are really looking to actually in the next version see an AI agent that not only acts on the on-chain data but also acts on the off-chain data, let it be social or something else. It's entirely possible.
Now, one thing I just thought about and it blew my mind, and the Taraxa network would be perfect for this example. So back in 2017, I was working with a project on the Ethereum network, and they created the technology to lock and unlock a door by sending a transaction on chain. What do you think if a developer was able to create that for the Taraxa network?
I think it's perfectly feasible. It feels like a very trivial use case though, but very powerful.
What do you mean by trivial?
With the current technological advancements and the tech that we have at hand, you could do that in like a matter of seconds with Taraxa, and it's going to be quick. It's going to be cheap. If you just have everything to do that.
Well, that's what I'm thinking is if a developer wanted to build a product for, say, office locks, or they wanted to create their own lock brand and implement this technology inside door locks that you would see at Walmart. If you wanted to walk in and get a new doorknob at Walmart, but you wanted blockchain technology, why is nobody advancing to that intersection yet? And I think about a network like Taraxa, where the transaction cost is so low that when a developer developed that type of technology, they could include, say, 10 Taraxa on that wallet that is connected to the door lock, and that person would never have to refill it. They could run the transactions forever, locking and unlocking their doors. It'd give you 20, 30 years worth of locking and unlocking your door with 10 to 20 Taraxa tokens. That's what I'm thinking about. Different use cases like that. Them really intrigue me.
Yeah, I think that with the birth of blockchains, and really like our journey in the last 10 years was all about scalability. And after 10 years, we arrived to the point where we are just so enclosed in our own blockchain world that we don't really look towards what's out there. Like, let's be realistic. Like, it's inside the crypto world right now, it's chain eats chain. Like, that's the theorem of like, I'm just going to eat the market share of Ethereum, and then Solana comes in and I'm going to eat the market share of Ethereum, and then Taraxa comes in and I'm going to eat the market share of Ethereum. No, with Taraxa we don't want to do that. The majority of the market, 97%, really 97% of businesses have no tangency with blockchain, have no whatsoever done on blockchain. That's the real market. And that's what I'm iterating every single time when there is a debate, when there's a Twitter space. Why is, I don't know, any layer 2 really trying to tap into the market share of Ethereum?
Right. Doesn't make any sense at all.
It doesn't make any sense. Like, you're not expanding to the right direction. We are not going to, like, this is not going to be really like any utility driven efforts are not done, because we are just so enclosed in our own bubble that we want to kill
inside
the other chain.
The blockchain ecosystem, instead of looking out what's out there. How do you expand to these different markets?
Yeah, it's like the genesis story for Taraxa was really interesting, because like there was this IoT project in which we had a like inbuilt IoT device that provided origin data for a specific item that like was traversing long amounts of like ship sailing,
Okay.
kilometers.
Yep.
And after that, since we already had the technology, we decided to become an open source, open blockchain. So, like for Taraxa, it really was the other way around, not like any other decentralized ledger technology there that just like wanted to build the chain because I mean there's so much TVL on Ethereum, like it doesn't make sense, right?
Right.
um I think that's the really like the anomaly right now in the current market too. Like everybody is so focused on trying to capture the value that's inside the blockchain ecosystem per se, that nobody is looking towards, besides maybe the RWA guys. Like RWA is
Yep.
actually like I'm really happy with that narrative being like so popular, because that's like half a step towards general adoption, not exactly a proper adoption, because we're just still storing like contracts or some legal documentation on chain, and or the
Yep.
data that's required for the legal documentation on chain. But it's a small step, right?
It's a
it's
start in the
it's and
right
it's a small step.
direction. These people
Exactly,
are starting to
exactly.
look at what, and that I love the term real world assets, because you look at the things around you and there are probably only 25, 50 good RWA projects out there right now. That is an untapped potential, but you could start to throw some of these other ideas in under the RWA sector. When you think about that, um, lot company I just mentioned, if a developer wanted to create that technology, that's still considered a real world asset. That ties into what's happening in the real world. So I like that a lot. Is there anything else that you think we should touch on before we close out the interview?
Yeah, so I think that, just like circling back to your idea, I just have a water bottle right here. It has all the identifications, and like it says like it has the like recycled sign there. But
Yep,
is it really recycled? It would be so cool to actually see how many recycling cycles was it through, where is
that'd
the
be
material
cool.
coming from.
Yep,
How cool would that, like to have a world like that be like? Us at Taraxa, we are building something for the future that to look like that. uh, our goal, I mean, it's visible in our market cap too. It's not really just to like be the coolest layer 1 and the coolest guys in the current blockchain ecosystem. We build technology for the future, and we build technology for actual use.
that's sweet.
So that technology, if you want to build something like that, if you want to be a recycling company that actually has records publicly on chain, come to Taraxa. We are going to support you 100%, 110% to build
And
that
you
thing.
can do that for a low cost when it comes to them type of transactions on the Taraxa network.
Yeah, I think that's the base barrier right now. If you're looking to go on like a highly esteemed ecosystem like Ethereum or Polygon or whatever, it's realistically unfeasible to pay that amount for gas fees for transactions. I mean, you're not making that amount of money in recycling, right?
Right.
But new chains like Taraxa come, and new chains that are going to adopt the BlockDAG theorem and the BlockDAG evolution are going to come, that are going to make it sure that like, yeah, this is going to be possible. And I think the last thing that I would like to definitely touch on is really how badly the like evolution of really scaling layer 1s happened, and like how we are really going to the wrong direction, I think. Because you have, the OP stack, optimism, arbitrum, different type of layer 2s that are just using centralized sequencers to like, yeah, just pull in create a new network, pull in transactions, squash them into one big transaction, and then put it on Ethereum.
Yep.
I think that I know quite a lot of people from OP, and what they did makes sense from the perspective of scalability. But didn't they just go full circle on decentralization with that solution?
Yep.
Like, you have a centralized masterpiece of like application called the centralizer that just like makes or decides what's happening on the chain, what's correct or what's wrong on a chain. Isn't that a topic that we should definitely like talking about more?
All right. So when you look at Taraxa Network versus these layer 2 networks, like you mentioned, Optimism, let's say Base, Arbitrum, when you compare these types of networks with Taraxa, what would you say is the defining factor that sets you guys apart?
I think that we need to clear the air here, because first and foremost, Taraxa has all the layers required to run as a layer 1, a scalable layer 1. OP stack layer 2s and ZK stack layer 2s don't have a security layer. That's why they rely on Ethereum to actually settle their transactions. Now they also have this centralization factor that we discussed before with sequencers in mind, and I think that's more than enough.
So the BlockDAG aspect is what sets Taraxa Network apart from these standard layer 2s?
Truly. And one very good addition there is that we are not only running on BlockDAG, meaning that like it's much easier to include blocks inside the network, but we also have an adjustable weight of block creations, meaning that if the network is getting congested, then it's just going to sense that, hey, something is going on, more people are using us. So it's not only going to react with actually increasing the gas prices, which are going to be negligible anyways, but it's also going to decrease the weight of like how much effort it requires for you to create a block.
Okay.
So this ensures that its scalability remains intact.
That's
this is a countermeasure to actually like significant congestion, and we have tested this. We are 100% sure that it lasts.
That's awesome. Well, this has been Taraxa Network, BlockDAG Layer-1 with Ellard Varga. Thank you for being here, brother.
Thanks, Josh. It was an absolute pleasure. Hope to see you soon again.
The Crypto News Podcast with your host, Joshua Roomsberg. Follow and subscribe today.